We have another one. Let's go ahead and do the work. We're already here. Domain, take your denominator, set it equal to 0. We find that x equal to 4 is our restricted value, which means that when we set up our interval notation, we only have 4 hanging out on the inside. And our domain is going to be -infinity to 4, union 4 to infinity. Everybody gets parentheses. Now, for our g of x in simplified form, when I look at it, if I were to start by trying to factor the numerator, I would take out a -1 for my GCF. 2x squared minus 11x plus 14. If I go ahead and keep going, I would be looking for a product of 28 and a sum of -11. 4 times 7 gets me 28. When I add 4 and 7, I get 11, which means that I need to change the signs. My -1 is along for the ride. I would have x minus 7, x minus 4, divide by my 2, my leading coefficient, and I get -1 times 2x minus 7, because the 7/2 doesn't reduce, so the 2 comes up, times x minus 2 all over my x minus 4. So nothing canceled. Bummer. It factored though, so that's a plus. And that just means that our simplified form could be our factored form or our standard form, which we saw up above. Vertical asymptotes, remember that is what's left in the denominator, which in this case, x minus 4 equal to 0, tells me that we have a vertical asymptote at x equal to 4. Holes, since we did not cancel, we have no holes. Okay. Slant or oblique asymptotes. Remember, when we're doing these, we need to find the degree of the numerator and the degree of the denominator. Because nothing canceled, it may be quicker for you to look at the original unfactored form to find the degrees. Standard form, highest exponent, numerator is 2, denominator is 1. And here, the numerator is not only bigger, it's 1 more than the denominator, which means that we are going to have a slant/oblique asymptote. And we need to find it using polynomial long division. I'm not going to use factored form. I'm going to go back to the original. So I'm going to have x minus 4 on the outside, -2x squared plus 11x minus 14 on the inside. Remember, when you're doing these, we're only worried about the first terms. X, what do I need to multiply x by to get -2x squared? I need -2x. Remember, the next line comes from -2x times my entire divisor. Distribute the -2x through, so I'm going to have 2x times x, which gets me -2x squared. -2x times -4 gets me a positive 8x. And then remember, we change the signs when we draw the line. First term cancels. If it didn't, something went wrong. Go back and fix the error. 11x minus 8x gets us 3x. And we're going to bring down the minus 14. And then we start the process over. What do I need to multiply x by to get 3x? I need a positive 3. Since it's a positive 3, I'm going to put plus 3. So I need 3 times my divisor of x minus 4. Go ahead and distribute. 3 times x gets me 3x. And 3 times negative 4 gets me negative 12. Change the signs when you draw the line. First terms cancel. If they didn't, something went wrong. Go back and fix it. Negative 14 plus 12 gets us negative 2, which remember is our remainder. So we found our slant or oblique asymptote to be y equal to negative 2x plus 3. Our y-intercept comes from plugging in 0 for x. You can plug this into the original or into the factored form, whichever works best for you. If you plug it into the original, we would have negative 2 times 0 plus 11 times 0 minus 14 all over 0 minus 4, which gives us negative 14 all over negative 4, which reduces to 7 halves. So we just found our y-intercept to be 0, 7 halves. Our x-intercept, remember that we set it equal to 0. So we're really only concerned about the numerator. So we would have that negative 2x squared plus 11x minus 14 equal to 0. But we have already factored this. We said this factored in a negative 1 times 2x minus 7 times x minus 2. Because we found it when we were trying to simplify. Again, equal to 0. Negative 1 equals to 0. Negative 1's never going to equal 0, so we just get rid of that. 2x minus 7 equal to 0 tells us x is equal to 7 halves. So our first ordered pair for the x-intercepts is 7 halves comma 0. Then we have x minus 2 equal to 0, which gets us x equal to 2. Ordered pair of 2 comma 0. A lot going on, but let's go ahead and graph it. Again, first thing that we need to do is set up our x and y axes. We have our y vertical. We have our x horizontal. We had a vertical asymptote of x equal to 4. 1, 2, 3, 4. Dash line because it's an asymptote. So x equal to 4. We had our slant or oblique asymptote of y equal to negative 2x plus 3. So when we're graphing that, remember our y-intercept is 3. So I'm going to start there. And our slope is negative 2 over 1. So I'm going to go down 2 to the right 1, down 2, right 1, and I'm going to go all the way across the page or across my graph. Down 2, right 1. If I want to go back, I'm going to do backwards. So I'm going to go up 2, back 1, up 2, back 1. And connect them with a dashed line because it's an intercept, or sorry, because it's a asymptote, and we can label it. Now let's plot the ordered pairs we already have. We have 0, 7 halves. 7 halves. 7 divided by 2 is 3.5. So 1, 2, 3.5, hanging out right there. We have 7 halves, comma 0. We have 2, comma 0. So let's see, 1, 2, comma 0 is here. And we have 7 halves, which we said was 3.5, comma 0. So up above, we're going to come down close into this y and then shoot back up. We need to figure out what's happening on the other side of the x-axis, or sorry, the vertical asymptote. So here, next side after 4 is 5. You can plug into either the unsimplified or the factored form. I'm going to review how to plug it into the factored form. We would have negative 1 times 2 times 5 minus 7 times 5 minus 2 all over 5 minus 4. I'd have negative 1 times 10 minus 7 times 3 all over 1, which gets me negative 1 times 3 all over 1. Negative 9 over 1 is negative 9. So I have my ordered pair, 5, negative 9. So if we go to 5, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're here, which means that our graph getting close to our asymptotes is going to look something like that. Now the blue and the green lines are our asymptotes, so they will not be solid lines. The actual graph of the function, it's what's in that pink magenta color.